This is Lab 3, Circuits. The purpose of this lab was to use energy and conservation principles to understand how voltage and currents behave in a circuit with resistors and capacitors. Key concepts include Ohm's law, which calculates voltage relating it to resistance. Resistors in series. The resistors are connected end to end and have equivalent flow of current through each resistor. Resistors parallel. Resistors are connected side by side and have the same voltage across each. That's supposed to say resistor, sorry. Charge conservation. The amount of current entering each node is equal to the amount that comes out. And energy conservation. In a closed loop, the sum of all of the potential differences is 0. Introduction of brief overview of the results. The current and voltage we found to be 0.024A, and the resistance we found to be 47 plus 100, which confirms that it is a series. For part 2, the time for the voltage drop. For the 10 ohm resistor, we got the time constant to be 10 seconds, and then the 20 ohm resistor, we found the time constant to be 20 seconds. The system being the circuit, the batteries, resistor, capacitor, wire, etc., and the surroundings is everything else. Experiments. The first part was the DC circuits. We had to assemble the circuit with 2 ammeters, read and record the ammeter, and then reverse one of the ammeters and record the results. Convert the ammeter to a voltmeter and then measure the potential differences. Then confirm that the sum of the voltage drops is equal to the battery voltage. Then we had to plot the potential versus the position around the loop. Connect the voltmeter and the ammeter parallel with the resistor and record how they change in current, and then calculate the resistance using R equals the change in voltage over I. Oh, sorry. The second part was the RC circuits. We had to set up the RC circuit with the battery, resistor, and capacitor. We had to connect the battery and observe the bulb brightness over time. Remove the battery, then connect the capacitor to the bulb and observe the light. Then record the charging or discharging time. Determine the time constant from the circuit, and then repeat with the second resistor. So this was the experiment. Some pictures of our circuit. Experiment, possible room for error. The circuit could have been set up incorrectly. Some of the ammeters weren't working correctly while ours was reading. There's a slight chance readings could be wrong, and too much humidity in the room could cause some errors, potentially. Results, the DC circuit, we found the current to be 0.02A, like I said before. The voltage drop, for the 47 ohm, it was 0.97, and then for the 100 ohm, it was 2.04 volts, and the sum we found to be 3 volts. For the RC circuit, charging, the bulb was initially bright, then dim as a capacitor filled. Discharging, the bulb had faint light, but then faded, and the current and voltage decreased. The time constants, like I said before, 10 ohm resistor, the time constant was about 10 seconds, and the 20 ohm resistor was about 20 seconds. What if? What if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. Use an ammeter to measure how long it would take to charge the capacitor when connected directly to the battery, or the ammeter. Discuss why measured time is different from the predicted time. If we were to attach the voltmeter to the circuit, the voltmeter reading wouldn't change because there isn't any current flowing through it due to the high amount of resistance. If we were to replace the voltmeter with an ammeter in parallel, the current increases and the ammeter would read incredibly high because it has a low internal resistance. If we were to change the resistor value in the RC circuit, the resistance would slow down the rate of discharging because the time constant increases with R. Conclusion. In conclusion, this lab effectively demonstrates Ohm's law, Kirchhoff's rules. We measured the voltage drop between the 0 ohm and the 10 ohm resistors, added up to be a total of the battery voltage. We also measured the time constants to be 10 seconds for the 10 ohm and about 20 seconds for the 20 ohm. Overall, this experiment demonstrates how resistance capacitors are confirmed with both principles of energy and charge conservation.